Hi everyone, my name is Paul and welcome back in the new lecture. So in last lecture we saw that when we provide the hinge support to a beam, it never restrain in the three direction. It always provide the limitations or support to the forces, but not to the restraint condition. It allow the movement along the XYZ direction. But if you provide the fixed support always provide the restraint condition in all the direction, and also it provide the loading condition, the support condition to the forces. So what we have to do is just check in this video that we will provide the support like fixed support at the both end, and the intermediate support will be the hinge one. So let's see how the behavior of the beam can be identified. So click on OK. Let's click over here. So we want the four supports. Okay, this one, the distance is 12 meter, and this is one, the one and one. Now click over here, grid spacing data. Okay, let's click over here. So A to B distance I want to provide as the 6 meter. B to C distance I want to provide as a 2 meter. C to D distance, okay, I want to provide as a rest, okay, 4 meter. So it become, okay, 6 plus 4 is 10 and plus 2 is 12. And click on OK and OK. So we have this overall beam pattern can be created. So after that, you can see 6 plus 2, 8 plus 4, 12. Right? Now just go in a plan and go to the base story. Okay, because all are the beam are always in a base story. Now click over here in the properties, assign the material, add new. I'm going to provide M25 grade of concrete. Click on OK, OK, and add a frame section of a rectangular beam of around the distance of 300 by the dimension of 300 by 300. Okay, wait a minute. And using a material as M25, 300 by 300. Okay, and click on OK. After that, just click over here. Okay, just select this property as 300 by 300 and assign over here. Okay, so it's assigned to all the property. Okay, you need to change everyone. Just wait a minute. Just select this property. It is very not it is not good to assign the property over here. Okay, if you click over here, it will assign to all this property. Just select properly. Okay, so you can see the odd in 3D. You can see the beam is assigned over here. If you click on this, you can rotate the beam like this. Okay, now just select this support and this support where we are going to fix support. So we just selected two end supports, assign the joint and restraint. So if I click on the fixed support, you can see the rotation about of XYZ axis will locked. Okay, so this is a factor, this is the important portion of the fixed support. If you want to lock the translational and the rotational in all the direction, you need to assign the fixed support. Okay, so click on apply. Okay, after that, these two intermediate supports we will to provide the hinge support. Okay, so hinge support if you provide, so it will never allow, okay, it never protect you against the rotation. Okay, and click on apply. Okay, now let's provide a loading conditions. Okay, so select this beam first, go to the assign, frame load, distributed, select here instead of the gravity direction, select the global Y. Okay, and then click on absolute distance and assign the load whatever you want to apply. Every time applying the load of the masonry wall minus of 25, okay, apply the minus of 25, apply. Okay, again select this and select this, go to the assign, frame load, distributed, global Y minus 25, apply. Okay. Now let's also provide some point load also in this span. So select this span, go to the sign, frame load, point load in Y direction. Okay, at a distance of okay, absolute distance, it is a 2 meter distance. So at a 1 meter distance in center, I want to provide minus of 10 kilonewton load. Okay, and apply. Okay, so you can see the minus of 10 kilonewton also applied. Understand? So now let's analyze it and let's check what are the variations we have. Okay, now we provide the fixed condition and hinge condition both. So you can see the various, various diagrammatical changes over here. You can see, okay, you can see the product very well. Okay, just wait and let's check in the proper direction. So now let me move this portion in Y direction so you can see it properly. Okay, so a model in Y direction now. Okay, this Y direction at top, Z direction will be on X direction here. Understand? Now, so beam deflection is like this. Understand? You can see the beam deflection is like this. If you want to rotate, just select this rotate button and just rotate like this. Okay, now let's check the shear forces and bending moment over here. Okay, so take the model at the top, click here, go to the here, shear forces, view with value, apply. Okay, so you can see the shear forces now 93.71. Okay, 30 minus 56, 37. Okay, and the 62. Okay, and you can see when I provide a point load, this kind of the movement is generated over here. Okay, so this particular pattern is generated, so it is very important to neglect this particular loading condition. So for that we need to assign the proper dimension of the beam. Okay, proper loading condition you apply, you cannot change the loading conditions, but you need to again apply the change in the volume. Okay, or just change the mixed design of concrete. Okay, or you can also during the analysis you can also look forward for the, yes, if you have that much amount of shear forces, so you can change the reinforcement. That reinforcement will carry the this particular kind of tension. Now you can see in beam, at the bottom always there is a compression, sorry, always there is a tension, and at the top there is a compression. So because this particular phenomena you can see, I can explain with this phenomena. At the bottom, at this bottom always you can see the tension, the loading conditions. Okay, this particular area is under the tension and this particular area in the compression, so we need to focus on this particular area. Okay, still we also applied lots of area over here. Why this particular condition may occur? Because due to hinge condition. Okay, this hinge condition allow the rotation against the XYZ direction, but this never allow the rotation against the XYZ direction. Okay, that is the main scenario. So now let's check the bending moment value over here. Click, just check the moment, apply. Okay, you can see the bending moment. Okay, this bending moment like this. The Y direction it looks like this. Okay, so the same value, whatever we are getting over here, it is in realistic figure, the realistic figure like this, but bending moment always look in our examination, we saw like this. So you can see the bending moment is not very huge. It's very less, 0.54, but shear forces is very high. What does it means? Your beam is not in that portion, okay, to carry the maximum. It is in a portion to carry the maximum loading, but due to which the maximum cracks can develop. The shear forces mean it will develop the cracks. Okay, it means it will develop the crack maximum over here. But in the term of the shear for movement, I can see that the deflections will not that much what we can see. Okay, because this value is reflecting with respect to the other value. In every software, when you can see the deflection, this all deflection you can see with respect to the present value. So accordingly 0.11, the 0.5 is very huge value. So that's why you can see the deflection like this. Don't go for the diagrammatical changes, go for the values. Okay, so today video we just stop over here, and next video I will try to provide to discuss about a cantilever beam here, where we can, let's check what kind of deflection we will get for the overhang portion. So have a nice day. Bye bye.